My name's Nick Henry. I'm engineering director here at SST Technology, and I'm going to be talking a little bit about, I guess, our journey into additive manufacturing and integrating additive manufactured parts into kind of complex metallic structures. So next slide, please. So a brief overview of who we are, as we're not the biggest company in the world, but gaining a reasonable presence in the industry now. So our background isn't actually in additive manufacturing, it's more in precision fabrication and thermal management systems for high-tech industries. So our roots have been within the motorsport industry and effectively making exhaust systems, but that has developed over the years into supporting a wide range of industries in that technical field. So in terms of company size, we're about 10.5 million turnover in 2019, with about 100 people, and hoping to maintain a similar level despite the challenges we've had in 2020. We have strong design and manufacturing capabilities, so we try to act as a technical partner for our customers rather than just a supplier. We have ISO 9001 and AS 9100 quality accreditations, and we achieved the nuclear AMRC's fit for nuclear status. And we have quite a large manufacturing capacity, so we've got 100,000 square feet factory availability at our base in Ensham, just outside Oxford, West Oxfordshire. Okay, next slide, please. So this is a little bit of a background as to our timeline through additive manufacturing development. So as I said, SST, or originally SS Tube Technology, was founded in the year 2000, really set up as a build-to-print fabrication house for exhaust systems. Business grew and was acquired in 2012 by new owners with a vision to enhance the kind of existing excellent kind of fabrication skill base with engineering quality and operational excellence, and diversifying away from just doing tubes for motorsports, and hence the rebranding to SST Technology at that time. Our first experience of working with additive layer parts was when we started integrating those into exhaust systems. So that started in around 2014, and we kind of learned there was quite a steep learning curve with us working with our customers to understand some of the intricacies of the design and the manufacturing at both levels, at piece part, and then the integration of that into these complex assemblies in the best way possible. At the same time, we achieved our ISO 9001 accreditation around about that period. So a few years went past, we kind of learned quite a bit, quite a steep learning curve, and in 2017 we were fortunate to win some Innovate UK funding on a project called Amalgam, which we worked on with the NTC, which helped us to initiate a capability in SST for the first time. So we invested in an AM400 machine from Renishaw, and embarked on a bit of a journey of the learning exercise I'm sure many of you have already gone through, in terms of understanding the machine, understanding the parameter development and process prove out, ultimately leading to 2019, we started manufacturing our first parts that actually ran on racing applications. So across Formula One, IndyCar, and Le Mans 24 hours, and sports car racing more widely. We have quite a range of customers, from those who are quite educated in using additive manufactured parts to those who have never even heard of it before. So it was quite a unique experience to introduce some of the parts into relatively new applications for our customers, and then that kind of development curve has increased significantly over the last 18 months, with us achieving approvals for some F1 specifications and also some diversity outside of just motorsport, but also into automotive, which has resulted in us investing in a second AM400 machine. So we've now got two of those working for us in our facility here in Ensham. We've also, at the beginning of this year, moved on to achieving IAS 9100 accreditation. So that's across the whole business, including our additive manufacturing capabilities. Okay, next slide, please. So I guess this now going into our approach, our work on additive manufacturing isn't just to make parts, it's really to include within assemblies and deliver solutions that include additive manufactured parts rather than AM parts in isolation. So there's a few examples here where you can see where the part we've designed and manufactured is actually integrated into a more complex assembly. So we don't just think about additive design for additive manufacturing at the early stages. We have to think about design for AM, design for machining, design for any post-processing like testing, and then also integrating the, I guess, design for fabrication and design for insulation where that's applicable. So we try to factor all that in along with the overall intent of what the customer is after overall into our front end design for additive manufacturing. So if we move on to the next slide, I can go on to a few more specific examples. So example one here shows a process where we started with some original unconsolidated customer CAD. So from a customer that had very little understanding of additive manufacturing. So we have gone through a process where we modified the CAD to suit the process. We've then broken down those parts into individual parts that can suit a single powder bed build program, and then obviously gone ahead and built those components. And that whole process is again considering all elements of it. So we would then have taken those final built components, we would have machined them, and then they would be fabricated and welded into a final assembly, which some more photos of that a little later. Next slide, please. This is another example where we're thinking about the design for AM and the post-processing. So there's a few examples of how we kind of enhance the built component to aid some of the further the follow-on processes. So the arrows indicated as one features that enable us to pressure test before going into machining. Two is examples of additional lugs for work holding during machining. We obviously have additional stock in certain areas for machining, final machining back. And then in some cases, there are stiffening features included within the build to help manage the thermal stresses that can occur in certainly some of the thicker and larger builds that often go hand in hand with heat treatment and stress relieving afterwards. Next slide, please. So this third example is I guess a bit of an overview of how our components can kind of sit and how they flow through the entire business, and the work that we do internally beyond additive manufacturing. So the first few of I've touched on. So we have the design and part assembly, so a lot of close work with the customer to take what they think they are looking for and add our expertise to hopefully result in something that's better than they were originally hoping for or intended. We then go through the usual steps of preparing the AM build with the associated test samples and density cubes and chemical analysis blocks. There's the build of the AM part. We then go through quality control. So we have the laser scanning and CMM capabilities to do full checks pre and post machining. We then go through the final machining and fabrication side of it. And in quite a lot of our cases, particularly with motorsport exhaust systems, there's insulation and heat shielding included. So we carry that out in-house, and again, that's a key factor we consider in the early stage design for AM, design for machining. It includes a design for incorporating the insulation, and the additive manufacturing process gives us some quite, I guess, that handy extra tools to really help us out with that final insulation process. Next slide, please. So looking ahead to the future, so we've gone on a bit of a fairly rapid development journey from not having any capabilities about 2.5 years ago through to now keeping 2 machines fairly busy. We're in line with our AS9100 accreditation. We're pushing and supplying parts to other industries outside of motorsport and automotive across all our fabricated and machined and insulation components. And we're looking to expand that and take the next obvious steps with our additive manufacturing capabilities. So our current focus so far has been on Inconel 625, which has served us well so far. But moving forwards, we have ongoing R&D looking at high specification nickel alloys, working with titanium alloys, additive manufacturing, and also looking at methods of joining those together. So that's either through additive manufacturing or other methods. We do a lot of dissimilar metal joining throughout our other areas. So there's some R&D there, and the parallels between the demands between certainly joining things like Inconel and titanium together are quite high in the motorsport industry, and the temperature profiles and kind of demands for those sorts of lightweighting options. There's certainly parallels within the aerospace industry. Next slide. And so yeah, I think that's about it for me. So these are my contact details. So yeah, feel free to get in touch separately, or if there's any questions, then I guess now's a good time for to take them.